Hello everyone. Welcome to the noon session, the first day of Library 2.011. We're really excited to be here chatting with you. Looks like we have about 40 folks in the room. My name is Jeremy Kemp, and Bernd Becker will talk about our backgrounds in a sec, but we're going to tell you about smart objects on the cheap, do-it-yourself interactive digital exhibits. And we're honored to have you here, and hopefully in the hour time that we have together, you'll get some useful information, and we'll get some useful information from you. So we're really looking for an interactive experience here, both for yourselves and for us. We need your feedback. This is a brand new topic, so please don't be shy. Let's go ahead and move to the next slide here. This is a new version of Illuminate for me. Well, I'm not, sorry Joe, I'm not seeing controls for move to the next page. There we go. And we have started the recording. Also want to thank especially San Jose State University, where Bernd and I are sitting right now, and these other fine sponsors. I really should have a backwards and forwards button. I'm wondering why I don't have that. Okay, well, let's talk a little bit about where you're from. I'll go ahead and give all of you whiteboard permissions. Hopefully Joe will do that for you.
I got it.
And then I will mark my own location here in San Jose.
So Jeremy, while people are loading, the forward and back buttons for the slideshow are up in the top right screen, top right corner of the slide. There should be little arrows left and right.
Got it. Yeah, the Page Explorer, which shows, right, okay.
Yeah, you're even next.
Yeah, I had that off the side of my screen, so great.
Okay, does everybody mark your place where you are in the world? Looks like we've got an Australian, somebody from England. Is it okay if we go forward to the next slide?
Okay, it looks like the sunlight is slowing down a little bit, so go for it. Well, like I said, we're really honored that you're here for this presentation, and we hope to get as much or more than you do from the presentation. We're going to talk about interactive exhibits in the library and exploring how to do them yourselves. So we've got a cute graphic here with some of the equipment that we use to prototype up our exhibits. So let me go ahead and move here. I'll talk about myself, and then Bernd can pipe in. I'm full-time faculty here at San Jose State, and previously I worked in distance education and worked on the learning management system here at San Jose State. And before that, I did product management in consumer electronics. So I've got a little bit of background in firmware and more of the technical topics. But mostly I'm an educator and working here at San Jose State. So Bernd, take it away.
Hello everyone, this is Bernd Becker. I am one of the social sciences librarians here at San Jose State University. I actually am a former student of Jeremy's. I had him while I was going through the MLIS program, and it's an honor to be presenting with him here today on just such a kind of a groundbreaking new topic. It's always a joy, and like Jeremy said, we hope that you just walk away with us with some great ideas and get the creative juices flowing.
And Bernd leapfrogged me. He's a tenure track faculty, and I'm just a lecturer, so I'll point that out. So let's talk a little bit about something that may have happened recently in our library. So we're going to introduce you to our friend Joshua Smithson. And Joshua borrows a few fiction books each week from the library every week or two. And he visits during the lunch break and spends most of his time in the browsing collection, never really walks onto an OPAC terminal. He's never visited the library website, and really his only interaction with the digital library that we hold is really just through this touch screen, and it's a checkout station. So he doesn't really have any access or any thought of access to our electronic or digital library. And he goes and borrows his books and then comes back with the books and he puts them in his Dropbox, and this is a completely physical interaction. So again, really no kind of time with the digital library. So Mr. Smithson's interaction with our library is pretty brief and pretty simple, and probably maybe even more similar to the majority of our public library patrons. He browses books with his hands on the books. He touches the touch screen, doesn't even type anything, and he uses the barcode reader to check out his book. And he returns. It's a hands-on Dropbox. Again, it's a completely physical interaction with the library. So he's a pretty typical kind of a patron. So our question, and the use case that we're exploring right now, is how exactly does Mr. Smithson ever learn about ebooks? Because we've got a burgeoning, a giant collection of new ebooks, and all of our librarians are very focused on creating new offerings for patrons using the ebook model. So we looked at, and we are looking at, giving Mr. Smithson a little bit of a nudge. We are wanting to give him a little bit of feedback when he drops in a box, and we're in the process of beginning the prototyping phase for a device that will say, thank you. Did you know the library added 76 new ebooks this week? You can ask for a sample at the checkout counter. So that's an interactive device that senses when that Dropbox is used and gives the patrons some audio feedback. So this is the only point of contact that Mr. Smithson would ever have that would ever make him even think about the library as a digital space. So that's the use case that we're looking at for Mr. Smithson. He would go to the desk and say, hey, you know, what's with these ebooks? So Mr. Smithson may be very digitally literate and have great machinery at his office and at home, but has never thought of the library as a place where he can connect with digital and electronic resources. So then the librarian or the person on the desk says, you know what, all the ebooks are right in the catalog. You need to do this, 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 and this. And Mr. Smithson's next step, hey, what's this computer for? It's an OPAC. And we can actually get, well, he wouldn't say that, but it's, you know, it's an access to the catalog, and I can see the entire set of ebooks. And by the way, I'm going to go back to my office right now, spend 20 or 30 minutes looking through the collection, and I'll probably check something out and put it on my iPad or my Android device. So we are looking at, that's a sample use case. So what we're looking at are smart objects or physical, inexpensive things. I mean, this is like a $30 computer, essentially, that will connect our patrons with our internet, the things that we have in our library. Right now we're looking at the most basic, simple kind of things. Nothing, you know, space age or science fiction. It's really straightforward. And people have been doing projects with these smart objects and microcontrollers for a decade. So important terms here that we'll talk about today are smart object. A lot of definitions for this. In our case, what we're thinking about is some physical representation of the digital library that our patrons can interact with. And we're using, actually, we've been playing around with the Arduino. There are other kinds of microcontrollers, these little tiny computers, also done by Parallax and another company, the Basic Stamp. So there are a number of these project prototyping boards. There's also an integrated development environment, an IDE. So we're actually, on our computers, we're doing a little bit of simple coding, and we're transferring that coding right into these little computers. So we have a free piece of software that's provided with the Arduino, these microcontrollers that we use to code up the logic. So for instance, when Mr. Smithson comes, the door opens, he puts in a book, it triggers an audio call, which lights up the speaker and plays sound back to him. So that's, I'll show you one of these sketches, call them sketches. Everything we're doing, all the equipment, all of the software, all the applications, everything throughout the whole chain is open source. So we use an application that's based upon, it's called Wiring, which was based upon another programming language called Processing, which came out of MIT. And everything that we're working with, all the physical things, software and all that, are covered under a GPL license, open source license. So Baron, take it away.
Thanks, Jeremy. As Jeremy said, and is just referencing in those terms, we're really going to be focusing most of the session on the microcontroller, the little computers, as the smart object that we're going to be discussing. But I kind of wanted to put this into context as well, and talk. These microcontrollers and Arduino, they're not the only types of smart objects that are out there. They're just some of the newest making it into the library, into the libraries. Some popular ones that you've probably seen or come in contact with. One would be the quick response codes. Those are often referred to as QR codes. Now these are just sort of evolved barcodes. They're actually two-dimensional barcodes. So whereas the traditional barcode, just those little hash lines, are read from left to right or right to left, QR codes, they're read not only left to right but also top to bottom. Originally, these were just designed to allow a quick decoding and encoding of information at a really high speed. I just read an interesting statistic about this, that there was an internet retail group found that during the month of June 2011, there were 14 million mobile users who scanned a QR code, and 58% of those users scanned a QR barcode from their home, while 39% were scanning QR codes at retail stores. So it is a QR codes. If you might have seen them now, they're starting to show up on prescription bottles and whatnot. It's just a really quick way to move some static information. You can see here in the image we have a QR code. Not we, but the image has a QR code where it looks like in that QR code, I think they probably embedded a link to the library's catalog or to a library's subject page. There's also RFIDs, radio frequency identifications, and those are really used for like a product. Recently, they're predominantly used right now for product tracking. You've probably seen them in parking or toll garages. They can, so that's a picture, I believe, of our Fast Track, what we have here in the Bay Area, and that lets people go through the toll lanes without actually having to stop, because these things can actually track and be scanned for up to about 330 feet. And those are also sort of the same things as our automatic key cards, where you just hold the little key card up to the little black box and it unlocks the door. That's an RFID. Some stuff, a little bit bigger types of smart objects, more expensive, more commercial. There's NFC. Now actually Google is getting really big into NFC. It stands for Near Field Communications. Basically it requires a smartphone or a Bluetooth phone, and this lets data be sent and received. And we're going to be seeing a big growth in this in the retail merchant sector. It's just making payments. It's really going to be developed right now for payments and whatnot. And you probably have seen this kind of in the news. NFC, near field communication, it's starting to pop up everywhere. Then there's AR, augmented reality, and it's a little bit more complicated. It takes digital content and combines it with real-time images. This is, AR in terms of sort of the library usage. It's slowly starting to be developed. It takes quite a lot of programming and technical expertise. I know here at the public side of our King Library here in San Jose State, they developed an AR walking tour of the downtown that you could walk around and follow this tour, and then when you're at a certain place, it's using GPS location, so when it recognizes that your phone and the tour are all in the same place, you can hold up your phone and see a picture of what that building would have looked like in 1930 or whatnot. Very cool. Both near-field communications and augmented reality are good, and they're solid. And what's great about them is that it's not just a one-way transfer of information. You can actually send and process information back and forth. But this actually requires the user to have another piece of hardware, like a tablet or a phone, and it also requires a significant just amount of programming and expertise. And that's where microcontrollers come in. And Jeremy, will you describe those?
Great, thanks, Baron. So The one that we're working with right now started originally, the programming language started at MIT, and now it's an open source package with microcontrollers that have. Let me show you a little bit of video, and hopefully you can see some of this. This is the board. You can see how small this is, and I'll move slowly because I know if, this stuff takes some time to load. So this is the microcontroller itself, and it is very flexible. It connects to a computer with a USB port, just like that. Has some power, and you can see there are these places to stick wires in. There are places to put sensors and places to put output, like LEDs or speakers. And then later on, a little bit more complex, I can combine these boards. You can see that. And now this board has the ability to play sound files from a micro card, just like what you get in your camera. So we put a bunch of sound files on that, and now this can play sound. So you can see that it's very flexible, and it's actually pretty darn simple. The coding language is very straightforward. Free application on Mac and PC. So inputs on one side, digital inputs, outputs for speakers and things like that. The application that we're looking at right now, would require this infrared LED. So whenever a book went through these two, it would break, just like when you walk into 7-Eleven and it breaks the IR transmission here. Then this board would play the sound file, the voice recorded as audio. So all of this is, take a couple of hours to wire this all together and to prototype it. So that's what made us really excited about these tools in particular, to do prototyping of smart object applications. Make it a lot easier than augmented reality, and even easier than QR codes and something requiring computers and cell phones to work with. That's why we're really excited about the topic.
So some of the examples that I had been giving just in different industries, what's the really big push between more complex smart objects is showing up in the retail market. Also in arts, a lot of art installations are starting to make use of this technology, just because of the cost is decreasing so rapidly, and the community support behind it is increasing dramatically. And we'll talk about that in a little bit. But where I first started getting smart objects kind of on my radar in terms of things to look forward to was from the Horizon Report. Now, if you've never heard of the Horizon Report, at some point today or after the conference, I really want to encourage you to just Google Horizon Report and get a copy of it. It's an annual summary that it's a giant document, but it's an annual summary and report that sort of charts the landscape of emerging technologies in relation to teaching, learning, research, creative inquiry, and information management. And in 2009, the way that the Horizon Report is organized is in different sections. So they'll look at technologies that are going to be immediately on the horizon. So with an adoption period of like just a couple months to now. And then they break it down, and then 2 years from now, 3 years from now. And in the 2009 Horizon Report, so it's about 2 years ago, they listed widespread adoptions for smart objects, and they predicted that to hit in 2013 and 2014. And the predictions sort of, I think those are built just, they're watching trends and looking at the cost of these materials. But they actually listed in smart objects, in the smart objects section, and you can see the link down at the bottom of the slide. They discussed libraries in great detail. And I thought that was very interesting, because the Horizon Report isn't necessarily dedicated just to libraries, but they were seeing that smart objects have a place in the library. And let's look at some of the things that they pointed us towards. So here in the King Library, we have something called the book counter, and as books are checked in, every book that's checked in gets registered up on the counter, and that's sort of a little microcontroller too, that we have a physical object, a physical interaction, a book getting scanned, a book getting checked into the catalog, and it's having a digital result. And in this case, it's just something simple of counting the number of books that have been returned. Actually, the community, both the public and the school here in San Jose, have gotten behind that. And when we hit the 1 billion mark, there was a party, and it was kind of a lot of fun. It was a little functional functional installation. I was talking about the RFIDs. You can see here in our administrations.
Sorry, just a second.
Yes.
Can we go back one slide? And I wanted to talk a little bit about the practical issues of doing that kind of a display.
Yeah, let's do that. The counter?
Yeah. I've got the video
Sure.
up. So this was a piece of art, installation art, put in the library when it was first built by Mel Chin, who did a number of installations throughout the MLK here. Some really interesting stuff. This was one of two digital and I wouldn't call this interactive, but one of two electronic sort of microcontroller projects. This one happened before this whole platform that I'm showing here. But so if we were to take that original, what I showed you originally, which was the Arduino, this one, and hooked it up to the reader display, the LED reader display, then all we would need then from that point would be an Ethernet port. And so here's the Ethernet connectivity system. This is the Ethernet, they call it a shield. The Ethernet connectivity, which would connect here to Arduino, which would then connect to the LED reader board. Then what I would need to do, let's just get a little bit more technical, is take the Ethernet connection here and go out to a website that would give me something very simple, like the numbers, just the numbers themselves. So I would have an intermediate, that would probably take some PHP or RSS or something like that. So it gets a little bit more complicated, but still not terribly expensive and pretty quick to prototype. So that's what this sort of digital display connected to web information is very doable with these tools. So thanks.
Sure, and Jeremy, just regarding the costs in today's value of let's say, recreating this counter that we see here on the slide, minus the cost of the LED screen, because that thing's huge. But what would be the cost roughly now in today's prices of this materials to build what you were just describing?
Well, yeah, like you say, the large majority of the cost is going to be this reader board. But I mean, the equipment, we'll talk a little bit about that later, but the equipment to do that would be easily less than $100.
So that's what fascinates me and gets me really excited about the smart object microcontrolling field, is that just the cost has the cost has just decreased so much, and I'm sure it's way different than the cost of when this counter was installed. But then some of the less more functional, less interesting types of smart objects in our library, as you can see, our little key reader. So we don't have keys, we have those little ID cards, and that in itself is radio frequency identification. It transmits the information to unlock the door, permissions, use, whatnot. They're everywhere. So again, just zero in on some current smart objects in the library. It's still very young in the literature. When we were doing our literature review on this, a lot of the literature actually just discusses QR codes and RFID possibilities. So RFID, the radio frequency identifications, that's actually, that fluctuates in cost. But when you're talking about putting an RFID tag into every single book, cost just kind of skyrockets on that. But there's a great article by a gentleman named I forgot his first name. His first initial is an A. We have it linked in our at one of our last slides with our lit and references. But Walsh recently wrote this article called "Blurring the Boundaries Between Our Physical and Electronic Libraries: Location-Aware Technologies," and he's focusing on using smart objects for focusing on the location-aware aspect of it. But Walsh, for library QR codes, he identified just linking print to electronic journal holdings, what I really liked is the bottom, second to last bullet, the finding the appropriate help. We've used that here at the King Library. So when one of our reference desks is closed or during off hours, we'll put up a sign with a QR code on it saying, need more help, scan this barcode. And what it does, it takes the person's device and directs them to more of the e-help. So we have, directs them to study guides, research guides, as well as text to librarian, email librarian, and 24-hour help. RFIDs, book recommendations, comments on a book, picking up messages for you or your course. Now remember, RFIDs, that's something that can happen automatically. So if a student walks into the library and they have an RFID device and we have a message for them, it could get sent, pushed out to them automatically. But of course there are issues with this in the library setting because RFIDs do track the user, and RFIDs, it's kind of in point of a debate about how they can be implemented without, in acknowledging and respecting a patron's privacy. So it gets a little complicated in that sense. Then Jenny Levine, she is known as the Shifted Librarian, and she did a blog post and some sort of an introduction on using smart objects and having a smart object not just be a passive hidden object, but something as a library space. And smart objects were created for collaborative storytelling, commenting on books. They had sort of big whiteboards. This was done in 2008, so they made their own whiteboards and really kind of interactive touch screens. And what I liked is that she was interviewing one of the designers behind a smart object as a library space, and he said, you could always go out and buy something better and faster, but part of the fun of this is you get the experience of look what I did as opposed to look at what I bought. And again, smart objects, some people are just going to hear about these and just feel like they're way, way too complicated. But the truth is, once you start tinkering around, it does become sort of a very fun, collaborative experience when you're working on people with this. And it does create that look at what I did feeling. And again, especially in times of short budgets and limited budgets, we're looking to see how can we cut corners and what can we do, what can we make ourselves, what's open source, what's freely available versus what can I buy. But then what Jeremy and I are doing, I called it an experimentals, is just applying this to a Dropbox, something like an automated Dropbox that presents information. We could have it linked up to the catalog to see how many books were added every week or total collection. So it's really all about thinking big and kind of starting small. So we're going to talk about different phases, identifying the problem, but just the freedom and access to the creative aspect of this is incredible. Pretty much the sky's the limit, and we're going to show you kind of how to put these together and where to get the code for them. So Jeremy, I'll turn this over to you.
Well, I think before we get a little bit more technical and practical, I would love to hear the 60 people in the room and some ideas that they have for, now that you've seen some of the stuff that can be done, what are some ideas you have for your own locations, either libraries or information spaces, or what is anybody doing this work? I guess that's the question. And if they want to do the work, what would they do with these tools? So I need to rely on Joe about how to get 60 people connected and ready to add content in some way. So Joe asks in chat, what ideas do you have for your location? What do you want to do with the tools? And if we can get some talkers, that would be wonderful.
Okay, so we we've got some questions coming in. We've got Diane asking, I want to figure out how to make the story audio postcards for the bulletin board. George would like to know, well, this is so new, I've played with this technology at home. I've made the Brain Machine before. What is the Brain Machine? Any of you know, or would you want to explain a little bit more about what that is?
Hi, Cheryl. I'm just going to answer your question. That I had not been introduced to this before Jeremy showed it to me. I mean, I had seen things on like the Makers Faire and these do-it-yourself blogs. Especially around Halloween, I saw people using microcontrollers to make their Halloween suits. But it is, we're going to show you, and we'll give you access to where the coding and all the setup for these things are. And at this point, it can be, the simple projects are really just step-by-step, following the instructions. The community behind this is very supportive, and it really is 100 times more simple than you probably might imagine.
Yeah, George, that link for Maker is very interesting, yeah.
Okay, well, I've got a question. You mentioned the augmented reality. I've seen some commercials where an ad for a smartphone where somebody's in China, they don't speak Chinese, and they see all these Chinese restaurants. They just hold up the phone, and then they can automatically see reviews based on, you know, where the restaurants are along the path in their location. Is that a use of augmented reality?
Yes, that is a perfect futuristic example. Google, I watch Google right now with these kinds of developments. They have something on their Android devices. I'm not sure if it's made it to the iOS version yet, but they have something called Google Goggles. It's Google Goggles, and it's something that it's constantly being updated and innovated. But you can actually take a picture of I think they use an example. Someone takes a picture of the Eiffel Tower, and then it'll immediately pull up all the related information on your phone about the Eiffel Tower. Now, a true augmented reality is going to place that information over the picture. As you saw kind of in that, some examples, mock-up examples, are that you take a picture of a building, it can show you what every floor, pops up on your picture, a little label saying, this floor is administration, this floor. There's also another one when you were talking about the language barrier. I think Google Goggles is being merged with Google Translate, and you can actually take with your phone a picture of an item or a document, or like even a piece of merchandise. Take a picture of it, and if the text is in a different language, just taking a picture will automatically find the text in there and translate it into English. And those are all just great growing applications of smart objects and augmented reality. What it's really all about is just laying information that's on the net, or the internet of information, and just drawing and pulling related, applicable, immediately related and immediately applicable information from the net, from the cloud, wherever, and bring it right to the person to meet their need at that moment, whether it's need to find out hours for a library, or this example with the library Dropbox, it actually comes from, the idea of it kind of came from a conversation I was having with a friend who, him and his wife and his child are constant library users, but they are the walk-in people. They walk in, go to the kids section, go to the browsing section, and check out. And I started talking to him about the ebooks, and he had no idea. And he kept asking, well, how was I supposed to know about these ebooks? How is anyone supposed to know? So it's just incredible applications for this technology. Jolene, I don't think, I haven't seen any cons for the different types of QR codes. I really like the logo multicolor. We have someone here in the library who built a QR code, and it has the SJSU icon in the middle of the icon. The only con I could think of with these elaborate QR codes is they can get to the point where someone might not recognize that it is a QR code. So just keeping that, not making it so creative and so obscure that no one realizes that it's a QR code. But I love the different types that are evolving now. And if you ever want to create a QR code, you basically just Google QR code generator, and they'll walk you through the whole process.
I want to share a resource with Elaine when we get a little bit further along.
Gee, I'd say go ahead.
So, Jeremy, do you want to talk about the just the phases of developing this project?
Right. So right now we're sort of in the middle of these stages 1 and 2. We have a goal. We know what the interface is, and we know basically what the outcomes are going to be. Then next step is gather the parts. We have most of those. Breadboards, I showed you some of those. Inputs and outputs. So we've got the infrared emitter and receiver. We've got the Arduino, and we've got the shields that we need. Next up is to wire the application and hack what we call a sketch, and I'll show you an example of a sketch. Somebody mentioned that, gosh, is it really that simple? I don't have any programming experience. And the thing about these is that this whole concept of microcontrollers and the Arduino platform is based upon making microcontrollers more accessible for designers and creative people instead of engineers. So the sort of the whole slant and perspective of this project is to make it more accessible to people who are spending creative time doing other parts of the project. So let me work you through this particular use case with Mr. Smithson. So our goal here is to increase the use of ebooks by non-digital patrons. Missing a quote. We have an infrared sensor which plays connected to another part of the system that plays an audio file. So it's very, very straightforward. And our outcome then is going to be inquiries to the desk. Mr. Smithson and all his brothers and sisters come and ask, what's this about the ebooks? And we would keep a tally on the desk. So that's the first phase of the project. The second phase is gathering the parts, and you saw the breadboards. Here on the bottom left is a little bit more complicated wiring schematic. And you can see that there is a number, you can see that right here, the number 7, that's created from the logic of this circuit. And you can see this circuit actually does not connect to an Arduino, so the integrated circuits are included right on the board. That's way beyond my skill. And we have the Arduino. You can see this. It connects to your computer with the USB. There's the chip, the logic, and then there are places to stick your wires for sensors and for outputs. So the next step there, looking at the inputs, here you can see some inputs, typical LED, well that's an output, but 7-segment LED, some components here, the speaker that would connect to the board, directly to the Arduino board. And then, so the next stage, step 3, is to get a little bit more technical here. The logic here, this is a very simple, this is sort of a hello world. It makes an LED blink for 1 second and then off for 1 second. So these are basically all the lines of code that you would download and install using the IDE. And this is the wiring diagram for this particular circuit. You've got an LED and you've got a resistor connected right to the Arduino system. And then, so we would download this and make changes to the sketch, make some changes to the wiring, and test it with users, and refine our design and retest with users, and work with that until we have something usable. So where do you get all these things? Somebody mentioned Maker. So if you go to makershed.com, that's a good place. For the components, you can buy them at Adafruit, A-D-A-F-R-U-I-T Industries. And Arduino itself, which is out of Italy, they sell the boards locally. Amazon.com sells all of this stuff. You can also go to makershed.com and buy it there. So the board I showed you, I'll get my video going here again. This is the Arduino selling for roughly $35. These breadboards for $5. This soundboard for another $35. So all these, the basic boards sell for $20 to $30. And this is the Ethernet connectivity. You put the plug your Ethernet cable there, and that's another $35. But it's interesting to know that the Arduino boards are open source, and there are clones. So this one right here, this was developed. This was created by Arduino and manufactured by Arduino. But this one, OSEP, was manufactured in China. So the whole structure of the board's open source, so anybody can create a clone and sell it for a little bit less money. That's interesting. So, Baron, do you have anything you want to wrap up with, and I'll talk about some of these references?
Sure. I'm going to post a link in the comments to my Google Docs. I have a Google Docs folder that will connect you to a scan of a Radio Shack ad. So if you have a local Radio Shack ad, I didn't even know Radio Shack was still in business, but they are, and they're apparently doing really well by selling these systems and kits. So there's some PDF scans of a flyer that Radio Shack just put out showing you how to create your own programmable Christmas lights using the Arduino. So if everyone's just looking for a fun project to kind of get started, you could follow those instructions. They have a list of all the materials and steps, as well as the code to do that.
So I wanted to share, her name is Leah Buchley from MIT, a prof at MIT, invented what's called the LilyPad. You can see it right here, LilyPad. And that is actually a sewable, wearable eFabric controller. So it uses the same logic as the Arduino, but you can sew it into fabric. It goes through the washing machine, and it actually connects to the other components in the system with conductive thread. So you sew out the project you want to do, and it all works. That's really interesting. It's round instead of these square boards. I gave you a link to a YouTube video where Leah presents, 2009, she presented a interactive or smart object pop-up book. So take a look at that YouTube video. YouTube has tons of great resources on this topic, some really interesting projects, none of them having to do with the library. So I think there's just a huge potential here for research and development in this area. Walsh, as Baron talked about earlier, gives a great overview of QR codes, RFID, and the basic concept of smart objects. And his thesis is really that all of these interactive objects are being used for logistics and mechanical sort of applications in the library. So like you saw that RFID going into the door, but they're not used for helping the patrons to connect in sort of an emotional, tangible way with the digital library. And I think that's really what this presentation is about, is that looking at these tools that mostly are used by hobbyists and really starting to brainstorm and spec out some use cases where we can engage our patrons in a more meaningful and interactive way that will bridge the digital library resources with their actual physical presence in the library. Because remember, Mr. Smithson, he has no access to that digital library, and yet all of the, a large amount of resources are being poured into that. So by opening a window between the digital library and the patrons with these very cheap and inexpensive and relatively easy to prototype smart objects and microcontrollers, we think there's a lot of opportunity here, and we're really excited about continuing on with developing these ideas.
So maybe for people just not sure where to start or how to, where you could apply this in your scenario, I mean, just think of if you're in a situation where your staffing has been cut or has shrunk, is there something that you could place in place of that person to at least get the patron the information that they might need? Like I used the example earlier about when our reference desk, if your reference desk has cut hours or hours are getting shifted around, definitely try putting up a QR code with an explanation saying, scan this with your phone, and to get information about when other sources of help or that the patron might need. Again, like I said, we point ours towards all of the online live help, but just what's some information, if you're having trouble thinking about how to apply this, what's some information that you just would like to push or pass along to patrons? Any kind of outreach activities, this is great for outreach. You can put QR codes on bookmarks and pass out bookmarks so then when they scan that, it could take their phone directly to your library's webpage. There's a ton of stuff. If you're at a school, I say put your library's homepage in a QR code, put those QR codes on bookmarks, print out 1,000 of them, and just start handing them out at the beginning of the semester or during freshman orientations. So we would love to hear any questions, any suggestions.
See, looks like doesn't look like there's any more questions. And do you two have any email addresses on any of the slides or other contact information?
No.
Okay, well, I'm sure if you Google Jeremy W. Kemp at San Jose State or Bernd Becker, there's probably not that many duplicates of you two at San Jose State.
That's true. That's true. Joe, is the chat logged? I believe it is.
Yes, it is. So Jeremy, if you could put in your email address, that'd be great too.
No, you got it on the slide.
Oh, there it is.
Well, we'd be very interested to hear the interactive pieces that you'd be doing. Oh, I did owe Eileen something here. Let me go down. Eileen, I wanted to, sorry folks, I don't know how to do this gracefully, but I wanted to show Eileen one of these resources, the open air museums, the McLaughlin, the Irish open-ended museum, open air museum. That kind of reminds me a little bit to your Amazonian cultural project. So tell us a little bit more about your Amazonian project.
See, which person are you? Do I need to turn the microphone on for?
Sorry, that was Elaine.
Elaine, okay. Elaine-esque. Okay, Elaine, do you have the microphone?
Yes. Can you hear me?
Yes.
Yes, I do. Okay. I worked with an Amazonian researcher who spent about 12 years in the Amazon with a particular tribe, researching their culture as it related to myths and their basket weaving traditions with images that have a deeper meaning because of the myths. And we wanted to be able to explain how it connected to people in an interactive way. So I created a picture book with cards, and each card had a fiducial, or the icon that the AR is triggered by. And then we downloaded images from 3D Warehouse, which is put up by Google through people just contributing their SketchUp models. And we were able to find images that related so that we didn't have to build the 3D models, because this was done as a student project at Digital Worlds Institute at the University of Florida. And then the participants could come up to the kiosk and use the movable cards to create their own versions of the myths once they read several examples. And because it was an interactive storytelling class, they could then make up their own ideas about what would happen with these characters that had been presented to them. So we presented the project and the whole augmented reality idea to the International Congress of Ethnobiology in Tofino, Canada in May of 2010. And my partner and I have been invited back to chair a storytelling session in the upcoming Congress in Montpellier, France in May of 2012. So it had a great effect. People were amazed by AR. They had never come across it, and it was a way to present it without having it be intimidating for them.
Wow, that sounds like an amazing project.
Well, we didn't have programmers that were part of the group that could have helped us move it forward with custom-made models, and to really use the depth of my colleague's information that she's gathered. So we would be interested in finding some kind of support from some entity that wanted to take it further, because she still is in contact with the tribal members, and she would love to be able to show them what technology can help them do. For instance, they possibly could market their baskets worldwide, and people would really understand the intricacy of the universe they've created that becomes the basket, that is almost a receptacle for their culture, which is not based on text at all. So that's one thing I really appreciate about some of this technology, is that it doesn't have to be based on text for those that are in cultures that reading is not an option or isn't integral to the culture. And as an artist, I guess I am attracted to visual learning. So, but thank you.
Well, yeah, you actually brought up a great point about using smart objects to interact with people in a non-text text setting. That's a great point.
I also think there's a connection here between the virtual worlds research, especially a setting like Second Life, which allows the designers to create interactive scripts, in the setting. So you go in, you walk into a building with your avatar, and you walk up to a little kiosk or a box, and you press it, and you get some interactive, some programmed interaction. And what's happening with the smart objects really is sort of parallel, because you're walking into a real space, you're walking up to an item, you're interacting with an object. So and even I've done coding in both environments, and there's a lot of similarities. So it's an interesting connection. The virtual world allows you to interact with 3D settings and models. The smart object, the microcontrollers, allow people to come into a physical place and interact with small, cheap items. Okay, well, it sounds like we've come to a close here, and I guess I moved to this last slide here. Turn off the recording, ask for okay, great. Well, thank you very much for coming, and we really appreciate your comments and time that you spent with us.
Yes, thanks a lot, Jeremy and Bernd. It was a great session, and I learned a heck of a lot, so thanks again.
Thank you, everyone.